We are absolutely swimming in data. I mean, every single day we're creating this tidal wave of images, videos, podcasts, and text. Now, for AI to be really useful, it has to do more than just read words. It needs to grasp the meaning behind all of this complex, unstructured stuff. So how on earth does it do that? Well, in this explainer, we're going to dive right in. Get this, by 2025, it's predicted that a staggering 80% of all our digital data will be unstructured. That's all the messy stuff, the things that just don't fit into neat little rows and columns in a spreadsheet. It's the raw fabric of our digital lives. A normal database is fantastic if you know exactly what you're looking for, right? Like a specific customer name or a product code. But what if you ask it to find something with a similar vibe or a related idea? Yeah, it's totally lost. This is the exact problem that a whole new kind of database was created to solve. To make sense of this chaotic, unstructured world, AI needed a new way to communicate. Not a language of words, but a universal language of numbers. A language of meaning that can represent just about anything. And that language is built on one core idea: vectors. Okay, let's break this down because it's super important. A vector embedding is basically just a long list of numbers. You can think of machine learning models as these incredible translators. They can take anything, a word, a song, a picture of your dog, and turn it into one of these vectors. And here's the magic part. Things with similar meanings get similar vectors. They end up being neighbors in this giant, multi-dimensional map of ideas.
Let me put it another way. A traditional database, it's like a spreadsheet. It's amazing for finding an exact match. But a vector database, that's like having a brilliant librarian. You don't have to give them the exact title of the book. You can just describe the concept you're after, and they know exactly where to send you.
And that brings us to the star of the show, the vector database, or VDB for short. These are the custom-built libraries designed to store and search this new universal language. They're engineered from the ground up to handle these incredibly complex vectors at massive scale and, crucially, at lightning speed.
So, how do these things actually work under the hood? Let's peel back the curtain a little bit and look at the two key functions that make these databases such a powerhouse for AI.
All right, I know this diagram might look a little intense, but at a high level, it's actually pretty straightforward. A vector database system is really broken into two main parts. Down at the bottom, you've got the storage manager, which is all about figuring out how to actually store millions or even billions of these vectors. Then on top, you have the query processor, and its job is to find what you're looking for, fast. Don't worry about all the acronyms. We're going to hit the important parts next. So these two parts have to solve two really big challenges. First, how in the world you store all these huge vectors without needing a data center the size of a small country? And second, once you've stored them, how do you sift through them all in milliseconds instead of hours?
To tackle that storage problem, they use a bunch of clever tricks. And a big one is called quantization. Honestly, you can just think of it as a really smart compression method. It takes those long, super precise vectors and kind of squishes them down into shorter codes. This dramatically cuts down on the storage space needed, all while keeping the essential meaning intact.
And this right here, this slide explains the secret sauce for speed. It's all about a trade-off. On one side, you've got the slow and steady approach, an exact search. This would mean literally comparing your search to every single vector in the database. Sure, it's perfectly accurate, but it would take forever. On the other side, you've got the rocket ship, approximate nearest neighbor search, or ANS. This uses smart indexing to take shortcuts, finding results that are good enough. And for most AI, good enough is perfect, in a tiny fraction of the time.
So let's connect the dots here, because this isn't just some abstract tech. Vector databases are the invisible engines that are already powering so many of the AI tools that we're all starting to use every day.
Seriously, from the recommendation engine that somehow knows exactly what you want to buy next, to that cool visual search feature where you can find a product just by pointing your camera at it, vector databases are humming away in the background. They're in fraud detection, they're in content discovery, and maybe most importantly, they are solving a massive headache for large language models.
And this illustrates what might be the killer app for VDBs today, something called retrieval augmented generation, or RAG. See, an LLM by itself only knows what it was trained on, which can be months or years out of date. A vector database acts like an external, long-term memory for it. It can instantly pull in relevant, current, or even private company data to answer a question, making the LLM's responses way more accurate and useful. So here's the bottom line. Vector databases are helping to ground these powerful language models in reality. By feeding them factual, up-to-the-minute information right when they need it, they help stop the models from hallucinating or just making stuff up. They're becoming an absolutely essential piece of the modern AI stack.
But of course, this is a brand new field, and it's moving incredibly fast. And with that kind of speed, you get some big challenges, and a pretty heated debate about the right way to build the future.
This quote really gets to the heart of the whole debate. Researchers are basically asking, look, if our existing, proven search technologies, like the stuff that powers Elasticsearch, can just be upgraded to handle vectors, do we really need to add a whole new, separate database to our systems? It's a really good question.
And that question sets up the two big camps in the industry right now. On one side, you have the native vector databases, companies like Milvus and Pinecone, who are building these hyper-specialized systems from scratch just for this one job. And on the other side, you have the established giants adding vector features to their already battle-tested familiar databases.
And that creates this fundamental trade-off. As a general rule, the native, specialized systems are often optimized for raw vector search speed. They can be incredibly fast. The extended systems, on the other hand, might not be quite as quick on that one specific task, but they give you a much more unified, all-in-one data platform, which is a huge plus for a lot of companies.
And looking ahead, man, this space is just not standing still. We're seeing huge pushes for better security and privacy, which is super important when these vectors can represent sensitive info. We're seeing serverless options for cost savings, more hardware acceleration with GPUs, and a big one, much better support for hybrid searches that let you mix the best of old-school keyword search with this new semantic search. All of which leaves us with one last big thought. As AI becomes the main way we interact with all information, doesn't that make the databases that organize information by meaning fundamentally important? It really makes you wonder, are these specialized new librarians about to become the most critical databases on the planet?
This is for entertainment purposes only.